Today's lesson we're going to be adding and subtracting rational expressions. So in the previous days we've simplified rational expressions and we've multiplied and divided them. Now today we're going to add and subtract. So remember that to add or subtract two fractions you must first get the common denominator and then keep the denominator the same and add or subtract numerators. So a very simple example, if you have fractions and you have 2/3 plus 5/3, that would equal 7/3. If you're subtracting and you have 8/11 minus 4/11, that would be 4/11. All right, so to get the common denominator to two or more polynomials, you must factor them using the steps we've learned in factoring. Find the greatest common factor using difference of squares, perfect square trinomial, or the trial and error method. The common denominator will contain each factor the greatest amount of times it appears as a factor. All right, so for example, if I was finding the common denominator of these three terms, first working with the 12, 15, and the 8. So I'd probably look at the largest number, 15, and then keep taking multiples of 15. So 15, 30, and I'm checking to see if 8 and 12 go into 30, which they do not. 45, 60, no, 75, 90, no, 105, no, 120, I think is a winner because 12 and 8 both go into 120. So that's the least common multiple of 8, 12, and 15. Then for your powers, you have a squared, you have a. Use the greatest amount of times it appears. So we would have a squared. We've got a b and a b cubed, so I would keep the b cubed. I have a c and a c to the fourth, I would keep c to the fourth. And so this would be the least common denominator of those three terms. If you've got polynomials like you do in the second one, you would factor each of these completely using the methods we did in class, not photo math. So if I take a 4 out, I'd be left with a squared minus 3a minus 4. And then by trial and error, I'd have a and a. I need one of each sign, 1 and 4, with the 4 being negative. In the second one, I could take an a out. That will leave me with a squared minus 9a plus 20. So I've got an a. I'd have a and a. And since it's a positive 20, both signs would need to be negative. And 4 and 5 would work. All right, so then find the least common denominator. Keep all of the factors the greatest amount of times that it appears. So I've got a 4. I have an a. I have an a plus 1. I have an a minus 4 in each one. And I have an a minus 5. So this would be your least common denominator of those two polynomial expressions. So a couple examples here of adding and subtracting rational expressions. And these are monomial expressions, meaning they have one term. So we're going to want to rewrite each expression with a common denominator. All right, so in this first example, I believe my least common denominator would be, of 5 and 10 would be 10. I have an a cubed and an a, so I keep the a cubed. I have a b and a b squared, I'd keep the b squared. All right, so then making the same denominator. So in this first example, I'm going to have to multiply the bottom by 2 to get that same denominator. And therefore, what I do at the bottom, I must multiply to the top. In this expression, to get 10a cubed b, I need to have an a squared and a b. And what I do at the bottom, I must do to the top also. So then I will keep that denominator. And on the top, I have 8 plus 9a squared bc, keeping those in alphabetical order. There is no like terms to combine, and so this would be my answer. So I got the denominator the same. I multiplied top and bottom to do that, and then I just kept the denominator and added the numerators. So in the second example, first one, my least common denominator of 16 and 5. I'd start with the 16, 32, 48, 64, 80. 5 goes into 80, so I'd keep 80. I'd have x cubed, and I'd have y squared. So that's going to be my common denominator. So in this first fraction, to get that on the bottom, I'd have to multiply by 5x cubed. And when I do the bottom, I must do the top. And in this one, I'd multiply by 16 and y to get the y squared. And when I do the top, or bottom, I must do the top. So then I would keep that denominator. And I'm going to subtract the top. On the top here, I'm going to have 15x to the 5th minus 8 times 16 is 128, I believe, xy. And that would be my expression there of subtracting those expressions. We'll continue this video in part 2.